Cool. Let's look at another polynomial question. This is from 2009, step 2, question 4, I think, if I remember correctly. So the polynomial px is of degree 9, and px minus 1 is exactly divisible by x minus 1 to the 5. Find the value of p of 1. Okay, well, if that is exactly divisible by x minus 1 to the 5, what could we do? Well, we could write something like, well, px minus 1 equals to, the x minus, no. The minus 1 is outside the bracket, isn't it? So x minus 1 to the 5 times some function, all right, some quotient, I suppose. Yeah? And let's chuck in 1. So if I chuck in 1, right-hand side becomes 0. Yeah, I don't really care what the qx gives me. So px minus 1 equals 0. So px equals to 1. Okay, gentle start to your question, right? So part 2. Okay, I'm going to make space. So show that p prime x is exactly divisible by x minus 1 to the 4. Okay, well, let's just differentiate, shall we? So, well, we had px equals to, what was it? So x minus 1 to the 5 qx plus 1 just now. Yeah? That was just what I wrote just now. So now I have p prime of x equals to what? So product rule, yeah? The 1 goes away, obviously. So I have 5 times x minus 1 to the 4 qx plus x minus 1 to the 5, and some people would say, oh no, I have no clue what q is, how do I differentiate it? Well, just write q prime of x, right? Why bother? Why bother? Okay, so this becomes what? This is x minus 1 to the 4 factorized, right? 5qx plus x minus 1 q prime of x. Yeah, so there is a factor of x minus 1 to the 4. Okay, part 2 done again. Right, this is quite a gentle question, actually. I wish I had that. So, part 3. Given also that px plus 1 is exactly divisible by x plus 1 to the 5, find p of x. Okay, so step questions, right? It might be sensible to look at the first 2 parts, and it might be sensible to do the same thing in the first 2 parts, yeah? So, what is p of 1? No, we don't need to find p of 1. We could just show that, p prime is exactly divisible by blah, blah. Okay, so let's do that. So, p of x now equals to x plus 1 to the 5 times, I suppose I shouldn't use q, well, some s of x, okay, another quotient, s of x, minus 1 this time, yeah, because px plus 1 is exactly divisible. Okay, so again, differentiate p prime of x equals to 5 lots of x plus 1 to the 4 s of x plus x plus 1 to the 5 s prime of x. Okay, so again, this is divisible by x plus 1 to the 4. Happy? Okay, so now what do we know about okay, let's look. So we know px is of degree 9, right? So if px is of degree 9, let's have a think. What do you think p prime of x is of degree? Of degree 8, right? Has to be. Okay, has to be has to work like that. Alright, or I suppose less than or equal to 8. Okay, well, I suppose it has to be 8. Okay, right, it has to be 8. Whatever. Okay, so if it's 8, then if I know that's divisible by x minus 1 to the 4, and I know it's also divisible by x plus 1 to the 4, well, then p prime of x has to be in some sort of form, k, which is a constant, times x minus 1 to the 4, x plus 1 to the 4, right? Because this is already of degree 8, right? So the remainder, the whatever quotient has to be a constant itself. Right? Okay, now the question becomes, how on earth do I find a constant, right? How on earth do I find a constant? Okay, so let's expand the right-hand side first, which is actually a pain. So this becomes x squared minus 1 to the 4, and by the binomial expansion, I have a k x to the 8 minus 4x to the 6 plus 6x to the 4 minus 4x squared plus 1. Okay, I suppose that should work. Hopefully that works. Okay, we got that? Cool. Okay, well now our mission is to solve for k, right? Now our mission is to solve for k. Okay, now we know p prime x is this. Right, we know p prime x is this. So, well, what can we do? Well, I don't know the values of p prime of x, right? So how about I go, let's say, p of x, right? What is p of x? Do we know what p of x is? We do, right? P of x is k times a 9th x to the 9 minus 4 over 7 x to the 7. I know this outer row is really annoying. 6 over 5, x to the 5 minus 4/3 plus x. Okay, and I suppose what can we do? Do we know if there's a constant or not? Maybe there's some constant, I don't know, maybe there's some constant, doesn't matter. Okay, fine. So well, what do I know? I know that p of 1 is 1, yeah, and what do I know? P of minus 1 is 1. So let's have a look at this equation here. What is p of minus 1? P of minus 1 is minus 1, right? Minus 1 here. Good. So p of minus 1 is minus 1. Well, I guess it just comes down to substitution, right? So what have we got? So 1 equals to k 1 over 9 minus 4 over 7 plus 6 over 5 minus 4 and 3 plus 1 plus c. Okay, and p of minus 1, which is minus 1, equals to k, and essentially the reverse of that, right? So it can't be asked, so let's do this. Minus 4 over 3 plus 1 plus c. Okay, and you could see that what does c have to be then? Well, c has to be 0 essentially, right? Because we know that c equals to minus c, right? So c has to be 0. Good. So the constant is gone. So now I have 1 equals to k. Okay, common denominator. Unfortunately, you don't have a calculator in the real thing, but obviously I'm going to use a calculator now because I'm lazy. So let's do that by a calculator. That is what? That is 128 over 315. Okay, well, I did actually want to try to do it mentally, but it's too much. Okay, too much for a day. So now I have k equals to 315 over 128. Yeah, happy? And what does the question want? The question wants px. Okay, so the question wants px, right? So you have to write px properly. What is px? Px is just k times that thing. Okay, and the c is 0, remember. Okay, so you go p of x equals to 315 over 128 of 1 over 9 x to the 9 minus 4 over 7 x to the 7 plus 6 over 5 x to the 5 minus 4/3 x cubed plus x, and there you go. Okay, well, it's quite a tedious question, but it's not hard, right? It's just lots of computation involved. Yeah, cool. All right, question done.